Alright, in this video we're going to be working towards this neat little demo here, showing a landscape that's generated from an audio waveform. And in the next few segments I'm just going to go over the basic requirements for this project, explain a few things, give you an overview of how I set up this particular demo, and then I'm going to go ahead and leave the rest up to you. Alright, so the basic idea is we want to take a snapshot of the currently playing audio waveform and apply that to a mesh somehow. In this case, I'm thinking just offsets along the vertical axis, which happens to be the y-axis. So first of all, we have to get this data somehow, and thankfully Unity provides us this handy method from the audio source component called getOutputData. So all we have to do is allocate a float array, give it a length that's at least a power of 2, and we also need to determine which channel we want to sample from. Now I'm just going to assume that 0 is left channel and 1 is right channel. And then we just pass that into this method. It's going to write in the data, and we have our samples. Alright, so now that we have our sample data, some of you might be thinking, well, great, we have a snapshot of the audio waveform. How does that translate into terrain? Well, if you've ever seen an audio waveform, oops, let me fix that. Might look something roughly like this. So let's say we have a peak there. We might have a little valley over here. Maybe this one goes down quite a bit because it's a pretty big change in volume. And we'll go ahead and just add another one over here. Alright. So if you use your imagination, and this kind of looks like a cross-section of maybe low poly terrain. Now, the problem is, if we just apply this to the entire mesh, we're going to get something like this, which, while it might look cool, it's not really anything that I would consider to be terrain. So what we want to do is maybe we can somehow iterate each row of vertices. So we'll say we'll apply that waveform to this row. And I'm going to use soft selection just so the mesh doesn't get all crazy, as I haven't triangulated this, and I don't want a bunch of broken graphics on screen right now. And let's say we go to the next row and we have some more sample data. There's a big peak here, and then maybe that peak dies off a bit in the next row and changes. And so we bring a little bit back down, and I'll just skip ahead a bit to get the general idea. So this looks a bit more like terrain. So instead of just applying it to the entire mesh, we're stepping through each row, and we're applying that sample data as offsets along the vertical axis. And once we're done, let's say it looks kind of like terrain. So all that being said, the next requirement of the project is, of course, some kind of regular grid. Now, it is up to you how you decide to get this grid. You could maybe go into a program like Blender, as I'm doing here, and generate a grid. You could use something else like 3ds Max or Maya. I decided to do mine in code just because that seems to be the easiest method. I can change the parameters in code at runtime. It's going to spit out an entirely different mesh based on what I tell it to do. And I don't have to deal with reopening the source file, re-exporting the mesh, that sort of thing. Second reason is also because, at least as far as Blender, it actually wraps its vertices in sort of an inward spiral. So it kind of goes, oops, control select, it goes kind of like this, and gradually works its way inward. That's just not going to work because we need our vertices to be laid out row-wise, so we kind of go like this, then the next row, and so on as we finish the mesh. So again, it's up to you how you decide to get your grid. If some other program works, that's great, but I've included the code that generates my grid in the project. I've documented it pretty heavily, so of course you're welcome to use that. But the big idea is that we need some kind of regular grid, and it doesn't really matter how many rows you have, so this doesn't really have to be square. You just have to make sure that the rows, the number of vertices in those rows, is going to be a power of 2. Technically speaking, it doesn't need to be a power of 2. You could do some kind of interpolation, a little bit of math to kind of map the sample data onto the mesh regardless of what size it is. That's just a lot of extra work. I don't really see it necessary to cover that. I'm kind of just giving you guys the basic idea here, and you're welcome to expand upon it as you see fit. Alright, so the final requirement for this project is some methodology or data structure that allows us to apply the sample data to the mesh easily. Now I've chosen to use a circular buffer. It just seems to be the easiest structure to do that with, and let me go ahead and catch this illustration to show you why. So this is a fixed size buffer, has 2 pointers, and as we write data in and fill up the buffer, we're going to come back around to the head and start overriding the oldest data. Now this is key because we're pushing in our sample data row-wise, and we kind of want whatever the oldest row is to get overwritten or kicked off into oblivion, whatever you want to call it. and that's going to kind of have the effect of shifting the data through the mesh, almost like this conveyor belt kind of way. And I'm sure there's other ways you could accomplish this. Circular buffer just seemed like the best way to me. And I didn't write my own. I kind of went the lazy route and found this nice implementation on GitHub. It's just an implementation of a circular buffer in C#. It is generic, so you can actually use whatever data type you want, which is nice. So you could even apply this in future projects. And Mr. Portela has made it available for our use without any stipulations, which is really nice. I love the open source community. But you can go ahead and use this one. You can write your own. Just make sure you have some methodology of applying the sample data to the mesh, similar to how I've done it, and you should get similar results. All right, well, I think it's about time I show you guys what I've done. So let's go ahead and fire up the demo here. And there you have it. It's a landscape that's generated entirely based on the incoming audio. And I'll just go ahead and briefly cover some of the configuration values we have over here. So sample count is exactly what it says on the box. That's the number of samples we're taking from the audio source, and consequently also the number of vertices per row. Height scale is just the maximum offset from 0 that we can have, so it's either going to be positive 600 or negative 600. The road extent is how wide the road is from center in terms of vertices, so we're going 24 vertices out in each direction from the center. And the road curve here is what sort of curves the data towards 0 as you get closer to the center of the road, just to kind of give us this nice fall off, almost as if this is a properly paved or constructed roadway. Height curve, this actually applies a curve to the data that sort of accentuates any peaks and valleys, just because there's not really that much dynamic range in the source audio, so everything tends to kind of stay right around almost like this level right here, but the curve sort of gives us these mountains whenever there's a decent peak. Update interval is just how many, how do I explain this? So this is updating every nth frame. So putting 2 here means we're updating every second frame. This can be kind of expensive just because querying a lot of data from the audio source depending on how many samples you have up here. But this also acts to sort of smooth out the data a little bit in combination with the lerp factor down here. So lerp factor is just the interpolation value between the 2 data buffers. So the farther towards 0 it is, the more influence the already filtered values from the previous frame have on the incoming data. And the closer to 1 it is, or farther right, it's going to increase the influence that the brand new data coming in unfiltered has. So if I crank this up, you can see things start getting much more pronounced. And if we go pretty far over, they start getting kind of absurd. So I found that the best value lies somewhere around 0.1 and 0.05. The rest of this is just the shading for the very basic material that I've set up for this. It's just a very basic shader that converts the local position of the vertex into a 0 to 1 value, and then samples a gradient texture. Inside the utility class, I've included a function that takes a gradient from the Unity editor and samples it into a one-dimensional texture, which you can then upload to a shader, and that's just a very easy way to get gradients into the shader. I'd recommend you probably don't use this because I wrote it in about 5 minutes. It's very purpose-built for the demo and not really, I don't know, it'd be kind of hard to sort of adapt and extend for any sort of project. But that's what I got. You could probably use this as a base for maybe an endless runner, or maybe some sort of racing game. It's really up to you guys, and I'm going to go ahead and leave you with that. So down in the description below, you guys can find links to everything I've used for this project, including a link to the actual GitHub repository, which is going to, of course, have all the source code, any assets I used, and this project itself, so you can just go ahead and dive right in. And as always, let me know what you guys think. I'm kind of starting the channel over. I don't know if this is the format I'm going to stick with. It's just the one that works right now. And I do apologize, this video took quite a bit longer than I thought it was going to. I'm a pretty big noob when it comes to editing, and also I'm not great with the whole YouTube thing, still working on that. So if I seem a little bit shaky or pause for uncomfortably long amounts of time, that's why. But I'm trying, and as far as the next video, you guys can probably expect something revisiting hover physics. I know some of my older videos, I did show off a few hovercraft designs, and you guys seem to really like that. So I'm going to finally take it to the next level, do a project on it, rewrite the code from scratch, and show you guys how I got really nice hover physics using cool things like PID controllers and actual Unity physics. But again, in the comments below, let me know what you guys think. If you have any suggestions, questions, concerns, whatever, I'll try to read them all. And if you like what you see, go ahead and hit the subscribe button and click the bell if you want to get notified. I don't really have an upload schedule. It's just kind of going to be whenever I have content. But I'll try to stick to something a bit more regular moving on. And I'll catch you guys in the next one.